Desmos on the SAT is a cheat code if you know what to press. In the next 6 minutes, I'll show you the exact clicks, graphs, and shortcuts to turn tough problems into quick solutions. Let's start with the layout you'll actually use. This is the Desmos interface. On the left is your expression list where you type equations. The big area is the graph. Use the zoom buttons or your mouse wheel to make it bigger or smaller, and when you press the plus and table, you get a table for regressions, which we will get into later. That is basically all you need to get an 800. Everything else is up to you. Let's begin with the easiest problem type that Desmos can solve: system of equations. Here on the left, I have put up the problem. We simply put both of the equations into Desmos and see where they intercept. The point of interception is the solution. If there is no interception, there is no solution. Here are some more examples. Now, sometimes a system of equations problem has an extra step like this one, but it is still simple. All we must do is plug in values of k until the lines are parallel, or in other words, have no solution. Next up is using Desmos to solve equations with one variable. Single variable equations can be solved by hand, but the problem with this is that it requires extra effort when Desmos makes it so easy. To solve a single variable equation in Desmos, all that must be done is this. Similar to system of equations, we must put both equations into Desmos and solve for the x value. Don't confuse it with the y value. The answer in this case is -34. Now, a quick trick when using Desmos. If you put an equation in function notation like this, you can directly insert x values to get y values. Keep that in mind for the last tip. Next up is number of solution questions in Desmos. When a question states, how many solutions does this equation have? This means at how many points does it intercept with the x-axis? Of course, the easiest way again is to use Desmos. To find these solutions, all we will do is put the equation into Desmos and observe it. It crosses the x-axis twice, so this equation has 2 solutions. Sometimes College Board will write the problem like this and ask how many solutions 2 equations have. The only difference here is that we are searching for the amount of times these 2 equations intercept. Here again, it is 2. The next type of problems are minimum-maximum problems. These problems are relatively easy. They will ask for a maximum or minimum value of an equation. Sometimes it will ask for the x value at which the min-max is found. So just be careful for that. Here is another problem being solved. Desmos is also really good with mean and median problems. This is all you must do to solve them. Type out the word and separate each value by comma like this. Now, before we get into the difficult to understand regressions, let's get inequalities over with. College Board may ask you to find which point satisfies an inequality. All you do here is type the problem into Desmos, type the points in alongside, and whichever lands on the shaded region is the correct one. Okay, so now we're getting into the more advanced Desmos tricks. Let's begin with regressions. Regressions can be used for all types of problems, like writing functions, solving for constants, and many more. Instead of giving a full in-depth explanation on regressions, let's go over it simply. We've got a table of time versus bacteria population. First, type the data into a Desmos table. Put time in the x column and population in the y column. Now, instead of guessing equations, let's try an exponential regression. In Desmos, type the equation with a squiggly instead of equals sign. That tells Desmos to fit an exponential model to our data. Make sure to give the x and y a subscript 1 for this to work. Boom, Desmos spits out values for a and b. You'll see something like approximately 50 and b approximately 2. So the regression gives us our equation. Looking back at the answer choices, that matches option B. So instead of crunching all the numbers, the regression tool helps us instantly find the right exponential model. Let's make another regression for solving for a constant. We're told distance equals k, t squared. That means we expect a quadratic relationship. In Desmos, we enter the table with time as x1 and distance as y1. Then, instead of typing a generic quadratic, we use regression to solve for k. Type y1 squiggly k times x1 squared. Desmos calculates the best fit value for k, and it comes out around 4.9. So the correct answer is B. This shows how regressions can help find constants directly from data and no need for any messy algebra. And that's Desmos in 6 minutes. With tables, regressions, inequalities, and system solving, you'll shave minutes off your test and boost accuracy. Practice these before test day, and you'll walk in with a huge advantage.